welcome back to my channel, and today I'm going to be talking about integration. In this video specifically, I'm going to be talking about partial fraction decomposition. So what is partial fraction decomposition and how does it relate to integration itself? As the name suggests, partial fraction decomposition is essentially trying to decompose a fraction into multiple smaller fractions, such that when we add those fractions together, it equals the bigger fraction. Now, what is the purpose in doing this? Well, if we apply this method and do this method, then we will get easier fractions to integrate, and therefore solve the integral faster, rather than doing multiple use substitutions or multiple integration by parts, or whatever method you're using. So that's essentially what partial fraction decomposition is trying to achieve, trying to take a bigger fraction and splitting it into smaller fractions such that we can integrate those smaller fractions and solve the integral. That's partial fraction decomposition. Now, let's take an example. Let's say we have 1/9 plus 2/6. Now, let's essentially add these together. So first we have to find a common factor. This is 36. Now if we do this, we'll get 4/36 plus 12/36. Now we can add these, therefore get 16/36, which will get 8/18, and in turn we'll get 4/9. Now we can do this with another method. So 9 times 2 is 18, 6 times 1 is 6, 9 times 6 is 54, to get 24/54, which by the way equals to 12/27, and we can divide by 3 to therefore get 4/9. So as you can see, we used both techniques and we got the same answer, 4/9. Now, essentially, is it easier to get 4/9 or is it easier to just get these two? Well, as you can see, it's pretty much harder from 4/9 to get to 1/9 plus 2/6. So there's a specific technique, which we're going to be talking about right now, of partial fraction decomposition. So our main goal in this video is to solve these two problems over here of integration. This one and this one. So let's first do the first integration problem. So we have the integral of 1/6x² plus 13x plus 7 dx. Now first, when doing integration by partial fractions, what we have to do is essentially we take the algebraic expression and trying to essentially factor it out. So this is just equal to the integral of 1/, then we have to write its factors. So 6x² plus 13x plus 7, so x² plus 13x plus 42, which will give us x plus essentially 7, and x plus 6. We can do x plus 7/6 times x plus 6/6. Therefore, we get 6x plus 7, x plus 1. And this is going to be our factored form, because when we multiply, we get 6x² plus 6x plus 7x. That's just going to be 13x, and 7 times 1 is 7, and we got the original quadratic equation. So we can just write these factors down. 6x plus 7 multiplied by x plus 1. Now the thing with integration of partial fraction decomposition is it's a lot of algebra, but it's way easier than just doing multiple use substitutions. So as you can see, we can divide this into a/6 plus 7 and b/x plus 1. Right now we're ignoring the integral sign, so we're just trying to focus on the algebraic expressions. So as you can see over here, we got a/6x plus 7 plus b/x plus 1. Now you may be wondering, where did the a and b come from? Well, we're trying to find the numerators. So that's the thing with partial fraction decomposition. We already get the denominators. We're just trying to find the numerators itself. So that's the specific algebraic step that we have to do. Now, we substitute these with a and b. So we can split these to a/6x plus 7 plus b/x plus 1.
Now let's just take the original fraction, 1 over, and we'll take it in the factored form, 6x plus 7 times x plus 1 equals to a over 6x plus 7 plus b over x plus 1. Now, let's multiply everything, essentially, by 6x plus 7 multiplied by x plus 1.
Well, what's the reason for doing this?
Well, as you can see, if we multiply by this expression, we will cancel these out, and we get a times x plus 1 plus b times 6x plus 7 is equal to 1. Now we can plug in values to essentially find a and b, so that's what we'll do right now. So let's set x equal to minus 1. If we do this, then this will just become minus 1 plus 1, that's just going to become 0, this will cancel out, and we got b, and then 6 times minus 1 is minus 6, plus 1, plus 7 is just going to be 1, which equals 1, so b is equal to 1. So we just got b. Now, let's do the same thing for a. So let's rewrite this. So we got 1 is equal to a times x plus 1 plus b times 6x plus 1. Now, as you can see over here, well, 6x plus 7. Now, if we have, so we have to get 6x plus 7 is equal to 0, minus 7 minus 7 over 6 is going to equal to x. We substitute this will just going to cancel out. Then we have to substitute that for x, so we have minus 7 sixths plus 1 is just the same as 6 over 6. Therefore, we get minus 1 over 6. So we got minus 1 over 6 times a equals 1. Now we can multiply by minus 6 to cancel these out, and minus 6. So we got a is equal to minus 6. This is what we got. So we got a is equal to minus 6 and b is equal to 1. So we can rewrite this as, so we can just substitute this for minus 6 over 6x plus 7 and 1 over x plus 1. Now, you may be wondering, what if we have tons of fractions that we just have to plug in? And it'll just be really hard to plug in for both expressions. Then can we do this algebraically? Yes, we can. So this is the algebraic type method without plugging in solutions. Right now, it seems pretty easy to plug in solutions, and it is, because we can just plug in the solutions, because the algebraic expressions over here are pretty easy. Now let's do it the pure algebraic way. So we got a times x plus 1 plus b times 6x plus 7 is going to equal to 1. Now what we're going to do is we're going to actually distribute this. So we got ax plus a plus b, plus 6bx plus 7b. Now as you can see over here, let's group the terms. So what I mean by this is we know a and b are going to be constant, or in this case, they're going to be numbers. So as we can see over here, we'll just get a plus 7b, we'll group them, and plus ax plus 6bx. ax plus 6bx. Now, if we just bring this up over here, we can just factor out the x's. So we got a plus 7b plus x times a plus 6b is equal to 1. Now, why are we going to group these terms? Well, algebraically, we can see that this has to equal to 1, and 1 is a constant. So where's the x term? Because 1x won't work. 1 times 0x will just become 0, 0 times 1 is 0, so that won't work either. So as you can see, there's pretty much no x value or x term in the right-hand side, if we consider this the left-hand side and that the right-hand side. So what are we going to do? Well, this gives us an easy hint. This just states that x times a plus 6b is going to equal to 0. Now this is one thing, and this just states that a plus 7b is equal to 1. Is going to equal to 1. Now we can start doing some algebraic manipulations, because if x and then a plus 6b equals 0, then we can state that x must equal 0, or a plus 6b is equal to 0. So let's just do a method of substitution. As you can see over here, let's just say that, well, 1 minus a is equal to 7b. Let's plug this in. So we got 6, oh, well, we have to divide by 7. So we got 1 minus a over 7 times 6 plus a times x is equal to 0. This will just be 6 minus 6a over 7 plus a times x is equal to 0. And this will, if we do 7a plus 7, so 7a minus 6a is a plus 6 over 7. So then we'll just get multiplied by x is equal to 0. Now as you can see over here, x can equal 0, or the inside term can equal 0. Now if we just state that the inside term equals 0, a plus 6 over 7 is equal to 0, we can get that a equals minus 6. And therefore we got that answer, a equals minus 6 over there. Now there's a simpler way to do this. You got a equals minus 6, as you can see over here. But what is the simple way? And this is also a pure algebraic way. What we can do, instead of just substituting this, we can just state that a plus 6b equals 0, because that's a possibility. We have x can equal 0, or a plus 6b can equal 0, because, or both of them can equal 0, because we really don't know. And a plus 7b is equal to 1. A plus 7b is equal to 1. Now, as you can see over here, we can just do a system of equations. So we can multiply this by minus, so we got minus 1. So minus a plus, well, negative 7b equals minus 1. And add these cancel out, so we got minus b is equal to, or minus 1b is equal to 1. Therefore, we essentially just got another pure algebraic way. So we got b equals 1. We can plug that into an equation, top equation. So a plus 6 is equal to 0, minus 6, a equals minus 6. So this is the pure simpler way to derive it, and that is the algebraic way. Now, essentially, we've already got the values. We got a equals minus 6 and b is equal to 1. We checked it through multiple algebraic scenarios. Now, if we erase this, we can start doing the actual manipulation. So now, as you can see over here, we can essentially just integrate this now. So we got minus 6 over 6x plus 7, and then we've got 1 over x plus 1 dx. Now you may be wondering, this looks equally as hard as this over here. Can't we just do u substitution or integration by parts, and therefore just get the answer to this? And yes, you can. You can probably use another integration technique, numerically or algebraically, to try to solve this. But as you can see over here, there's a specific property of integrals and in differentiation. This is just equal to the integral of minus 6 over 6x plus 7 plus the integral dx plus the integral of 1 over x plus 1 dx. Now these are equal to each other. And as you can see, if we factor out them, we get minus 6 times the integral of 6x plus 1 over 6x plus 7 dx. And as you can see over here, if we integrate this, we get the natural log of 6x plus 7 all over 6 multiplied by minus 6. And therefore, we got minus 1 times ln of 6x plus 1. Okay. This is essentially going to be our top part for 6x plus 7. 6x plus 7 over there. So this is essentially just going to be our top part, minus ln value 6x plus 7. And if we essentially just do this part over here, you can see that once we integrate this, we'll just get plus the natural log of x plus 1. So we got the natural log of x plus 1 minus the natural log of 6x plus 7 plus c. And this is going to be our answer. Now this is going to be our answer for the integration problem over here. Now, as you can see, this may have looked pretty long, but it's not much more technical than we have over here. So if you're pretty good at algebra, then you're pretty good at partial fraction decomposition, because pretty much at the end, we just use simple integration techniques, simple things that you learn at the beginning of an integration class, because this is the opposite of differentiation. When we differentiate the natural log of x, we get 1 over x. Similarly, when we integrate 1 over x, we get the natural log of x. So as you can see, they're opposites. So when we differentiate the natural log of x, we get 1 over x, and when we integrate 1 over x, we get the natural log of x. So these are simple properties at the end. So pretty much it's all just algebra. And we talked about different methods. We get the plug-in method, where you just plug in values. And we also talked about how we can use this pure algebra. We can use pure algebraic manipulation, substitution, elimination, and so on and so forth. So pretty much partial fraction decomposition involves a lot of algebra and some basic properties of integration. Now that we've talked about that, we can make this video to an end. In the next video, we'll talk about the second problem over here. If you like this video, if you like this channel, please subscribe to learn more. Thank you.